Okay, now that we have the inequality understanding in our head, let's go ahead and keep working here. It says the t-shirts they made were a hit, but they cost $180 to make, and they were hoping to sell enough to make a profit. Question number 1, how many shirts would they have to sell at $6 a piece in order to, quote, be in the black? So have a profit. Well, we know that the shirt sales have to be at least $180 in order for them to be in the black. So shirt sales, there's $60 per shirt, and that has to be at least $180. So how many shirts is that? Let me fix that a little bit. Looks like they have to have 30 shirts, at least 30 shirts in order to do this. So sell at least 30 shirts. Okay, let's go ahead and see the algebraic part of that. Again, this is $6 per shirt. We don't know how many shirts, so we're going to make that S. So 6 per shirt has to be at least, which is greater than or equal to 180. So let's divide that 6 over. So that means that shirts have to be greater than or equal to 30, and that's where that at least comes into play. Okay, so multiplying and dividing in this section. Same as what we did in the past with linear equations. Okay, let's look at this next one. It says the day of the walkathon was beautiful, 60 degrees with a slight breeze. However, as the sun went down, the temperature dropped 5 degrees per hour. They were told they would have to stop walking if the temperature was less than 35 degrees. So question, how many hours would they be able to walk? Well, we started with 60 degrees. And we have until 35 degrees. So 60 degrees minus what is going to give us 35 degrees? Well, it looks like they have 25 degree cushion is what I would say. Okay, well, let's look at that. If it's dropping 5 degrees per hour, so 5 degrees per hour times how many hours is going to equal that 25 degrees. So it looks like 5 times 5 is going to give us that 25. So they can walk no more than 5 hours if it continues to drop 5 degrees per hour. So how do we write that algebraically? That is the walking, the hours have to be less than or equal to 5. Okay, let's go ahead and keep that in mind because we are going to solve this algebraically. So 60 degrees minus the 5 degrees per hour has to be greater than or equal to 35 for them to keep going. Okay, so again, 60 minus the 5 degrees per hour does have to be greater than or equal to 35 degrees in order for them to keep walking. Let's go ahead and solve this equation. I want to get that hours by itself, so I'm going to subtract that 60 over. 35 minus 60 is a negative 25, so I have negative 5 hours greater than or equal to a negative 25. I'm going to divide that negative 5 off. Okay, I end up with my hours. I end up with my 5. But look at this. This says greater than or equal to. But finding it out verbally, we had less than or equal to. This less than or equal to makes much more sense because, again, we have a limit. Our limit means that we have less than. So something happens right here. When we divide by a negative dealing with inequalities, we have to switch the sign. So that is a big thing when dealing with multiplying or dividing linear inequalities. And we are going to write that in blue. When multiplying or dividing an inequality by a negative, you have to switch the sign. Okay? And we understand that, again, by looking at this real world problem, that once we divided that over, our hours can't be greater than or equal to 5, or else we would freeze and we would get in trouble because we were out on the track. So when multiplying or dividing an inequality by a negative, you need to switch the sign, which is what we are going to practice on in this section. So go ahead and get out the notes and vocab for this section. Okay, objective for this section are the same as last time. We're just adding on the multiplication and division part of inequalities. We're still going to solve them. We're going to graph them. We're going to solve real world problems, and we're going to write those linear inequalities. The book did a pretty good job of explaining what I just went over about the negatives. Here we multiplied by a positive, all was well. As soon as you multiply by that negative, then we have some problems. So if you're not quite sure what I meant about that, read this. This is another good way to look at it. They do also bring it up here. Okay, that multiplication property of inequalities basically just means we are undoing multiplication by division. Okay, we are undoing division by multiplication. So I am going to skip through that, but it is good information to have just to review every now and then. So let's go ahead and look at surveys. It says, of the students surveyed at Madison High School, fewer than 84 said they had never purchased an item online. This is about 1/8 of those surveyed. So how many students were surveyed? Okay, let's understand what this is saying. This is saying that 1/8 of the class is fewer than 84. So that's how I'm going to write this. 1/8 of the class is less than 84. And I'm going to say class or students equals that S. Okay, we have our inequality. Now let's go ahead and solve that. Remember, how do we undo a fraction? We multiply by its reciprocal. So to undo 1/8, I'm going to multiply by 8 over 1. 84 times 8, we have our class size, or our students, are less than 672. How many students were surveyed? 672 students were surveyed. Okay, so this under, again, 672 students were surveyed. Okay, again, read it one time, translate it into words, and then use that translation to write an inequality. Go ahead and try that for guided practice 1. Okay, rewording what they say is that 1/4 of the species of orchid species is more than 750. So I translated that to 1/4 S is greater than 750. Using the reciprocal of my fraction, I multiplied each side by 4, and I understand that my species are greater than 3,000. So what does that mean? That means that there are more than 3,000 orchid species in Malaysia. Okay, so getting used to that, now we're going to throw some negatives in there and see what happens. It does say we're supposed to solve negative 3/7 R is greater than 21, and we're supposed to graph the solution on a number line. So I'm going to rewrite that. And again, I'm trying to solve. So I'm trying to get that variable by itself. I have a negative 3/7 in the way, which means that I am going to multiply by a negative 7/3. I'm going to multiply by the reciprocal, knowing that that negative does have to come along. So everything canceled out over here. I am left with my R. Here's my rule. I just multiplied by a negative, which means that I have to flip that sign right away. Now I can go ahead and focus on this side right here. I can cross cancel. 21 goes into 3 7 times. 7 times a negative 7 is a negative 49. So I know that R is greater than a negative 49. Okay, with that in mind, I'm going to go ahead and graph this. I might as well start with negative 50. Then I can go to negative 48, negative 46, and so on. And maybe I'll do one more. I think I'm just going to leave it at that because I know r is greater than a negative 49. So I'm going to have an open circle at negative 49. I know it's greater than because, again, I did flip that sign because I multiplied by a negative. I know I have to switch the sign. Okay, multiplying and dividing. So again, with that in mind, go ahead and look at guided practice 2. Okay, let's compare these problems. This first one is the negative n over 6 is less than 8. That means that we have to get rid of a denominator of 6. We also have to get rid of a negative sign. So I multiplied by a negative 6. Multiplying by a negative, I flipped that sign and I solved. Same thing with 2b, however, this happens to be a fraction, so I multiplied by the reciprocal. Since it was a negative, I went ahead and flipped that sign. Look at 2c, a little bit different, because again, what I'm trying to get rid of is a 1/5. So I multiplied by a positive 5. Even though my answer turns out to be negative, that negative had nothing to do with what I multiplied by. So I did not flip the sign. Same thing with 2d. Negative doesn't even show up in the problem. I multiply by that reciprocal. I keep the sign the same, and I solve. So make sure you understand when to switch the sign, when to keep it the same. Okay, solving inequalities by division. Again, they go through all of these different steps and showing that as soon as I divide by that negative, I do have to switch the sign. They show all of the different division property of inequalities. We understand to undo division, we multiply. So with all of that in mind, let's go ahead and solve these inequalities. Then we're supposed to graph the solution. Just to get some practice with looking at solutions on a number line. So we have got 60t, and that is greater than 8. Well, how do I undo that multiplication? I'm going to divide by 60 on each side. 8 over 60 as a fraction is about 2/15. So this guy is really small. So we have t is greater than 2/15. Okay. How are we going to graph that on a number line? Well, goodness gracious. We're going to say 0 is right there, and we're going to count by 15s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 15. We're going to say that that's 1, because that way that each one of these is a 15th. So where's 2/15? Right there. We know t is greater than that, so open circle, everything greater than that. Okay, getting used to number lines, we can say whatever we want on those tick marks as long as we understand what they are. All right, let's go ahead and try B. Negative 7d less than or equal to 147. So again, trying to get d by itself, we're multiplying by a negative 7. So let's divide by a negative 7. 147 divided by 7. Look at this, divided. So right away, before I even look at that solution, I'm going to flip the sign. Then I'll look at the solution. Greater than or equal to a negative 21. Okay, so I'm going to start with negative 24. I'm going to skip because it's really hard to write these big numbers on here. So every other one, I'm just going to write the odd number, or the even number. I do know that it's greater than or equal to that negative 21, so here's negative 21. I'm going to fill in that dot and everything greater than. Okay, so understand what you're doing. As soon as you see that negative and you're multiplying or dividing by it, flip that sign before you forget. Okay, go ahead and solve and graph guided practice 3. Okay, 3a and 3b, dividing those out, not having to switch the signs because I'm not dividing by a negative. though I did have to flip 3b in order for that variable to be on the left, so I understood that that was less than or equal to -7. 3c, 3d, I did have to flip the sign because I divided. Understanding how to set up a number line if we are dealing with fractions, try to make it as easy on yourself as possible. And I do understand some of these number lines are small, so I apologize for that. But biggest thing about multiplying and dividing inequalities is that if you are multiplying or dividing by a negative, you have to switch that sign. With that in mind, go ahead and start working on the assignment for this section.